And the name of our new unit is functions. Now that doesn't mean a whole lot to you right now, but it's definitely more of an algebra type unit. The last unit we did, congruence and similarity, was more of a geometry type unit. We're talking about angles and moving shapes around the coordinate plane. That was last unit. This unit talking about functions, much more algebra, yet we do a little graphing at the same time. So let's get started here with this unit, and we're starting with something that's called a linear equation. Oh boy, I do like linear equations. Linear equations, but I guess before I even really read the definition, I want you to look at the word linear, and I hope that you see the word line. The word line is in the word linear because linear means in a line, right? That's straight line. So believe it or not, we're going to be working with equations that you're going to be able to solve them and plot points for them on the coordinate plane and graph them as a straight line. I know that seems a little weird that you're going to be able to take an equation and represent it using a straight line, but we are. So these are linear equations, and they are equations whose graph ends up being a straight line on the coordinate plane. And you may be wondering, how in the world are we going to do that? Well, here's how we're going to do that. These linear equations, and there's an example right here on this slide, I'll circle it. These linear equations have two variables. They have an x variable and a y variable, which are going to end up becoming your ordered pairs, which you're going to plot on the coordinate plane, which hopefully make a straight line. So they have an x and a y, which means they're linear, and like I keep saying it over and over again, you're going to end up plotting these points and graphing these points and connecting them to make a straight line. Okay, so as weird as this may seem, when you do this, when you plot these points and you make this straight line on the graph, all of the points on that line on the graph they're called solutions to the equations. So they are the x and y values, or the ordered pairs, that will solve the equation over and over and over again. There's not just one solution for this equation. There are many, really truly an endless amount. So let me show you how all this works. It says here in blue, you can use a graph to show the solutions of a linear equation. And in fact, you're going to today, and it had better make a straight line. We're making linear equations, straight line equations. And this graph that you see here on this page, believe it or not, represents that equation that I circled, where y equals x plus 1. Okay, here's how the math works behind all of this. We're going to use what's called a table of values. Over here on the left of the page, I'm looking over here, maybe. There we go. Here I am over here smiling. This is called a table of values. In a table of values, you get to choose the x values. It'll be blank when you originally start with it. There will be no values on the table at all. And you get to choose some x values. Now, I always tell my students you have to choose at least 3 values. And I would recommend that one of them be negative, one of them be the 0, and then one of them has to be a positive value. And you can choose anything you want, but if I were you, I would keep my values small, because you're going to be plugging them into this equation, solving it over and over and over again. You don't want really big numbers, because that gets really hard to graph. So you get to choose the x's, and I suggest you choose a negative, a 0, and a positive. And again, keep them small. So once you choose your x's, I'm going to write that equation over here so we can reference it easily. This is the equation that we're going to be solving. Once you choose your x's, you're going to take your x values and substitute them into that linear equation and solve it. And when you solve it, you will then get your y values. So check this out. The first one, for y equals x plus 1, you told me, or I told you, I guess, let's choose a negative 1 for the x value and substitute that in. So down here, down below, y equals x, we're going to plug in the negative 1, and then there's the plus 1, right? There's the rest of the equation. What's a negative 1 plus 1? It's a 0. That's where that 0 comes from in the y column. So then that becomes the ordered pair, negative 1, 0, which I'm going to go plot that point right now on this graph. Negative 1 means left 1, 0 means don't go up or down. There's that first point. Now let's solve it again. This time for the x, we're going to plug in the 0 right over here. We're going to plug that guy in. So y equals, instead of x, 0. And then there's your plus 1 from the equation. And when you solve that, you get a 1, which is where this red 1 in the table comes from. So now your ordered pair, when x was 0, y was 1. Let's plot that point. 0, 1 means don't go right or left. Go up 1, and there's that second point on my graph. And we have to do the third one. Got to solve these equations 3 times. Y equals x plus 1. For x, we're going to substitute in the 2 this time. Can't forget about the plus 1. So y equals 3, which is where that 3 comes from. So now that ordered pair is 2, 3, which means go right 2, up 3, and there's that third point. And lo and behold, when I connect those 3 points, voila, we have a straight line. If you plot your points, and one of your points ends up kind of out here, kind of wackadoo, not all lined up with the others, then somebody is in the wrong spot. That's why we choose 3 points. We choose 3 so that we know that it makes a straight line. If you just have 2 points isn't enough. And you can certainly do more than 3. If you wanted to do 4 points or 5 points, you could. Okay, let's try some. Here's our equation. We're going to graph the equation y equals negative 2x plus 1. You are going to use a table of values to do so. Which means you've got your x's, we've got our equation, this is going to be our answer of our equation, and then that's going to turn into those ordered pairs, which is what we're going to plot, which is going to make a straight line. Who chooses the x's? You do. Well, in this example, I'm going to. So I'm going to choose a negative 1, a 0, and a positive 1. I like those, and I choose them often. Now I'm going to substitute those values in to that equation where the x is. So here I go. Y equals negative 2 times the x, which I said was negative 1, plus 1. Now I'm going to do the math. A negative 2 times a negative 1 is a positive 2. Add 1 is 3. So that ordered pair is negative 1, 3. And I'm going to plot it right now. I'm going to go left 1, up 3. There's that first point. I'll do the next one in blue. Y equals my negative 2 times my x, which is now a 0, plus 1. Negative 2 times 0 is 0. Add 1 is 1. That ordered pair is 0, 1. I'm going to plot that. That's right there. Last one, y equals negative 2 times 1 this time, plus 1. Negative 2 times 1 is negative 2. Add 1 is negative 1. So this ordered pair is positive 1, negative 1. I'm going to graph that. That's the green dot. What do you notice when I connect my dots? Straight line. Yay! It's a linear equation. So I made my table of values, I plotted the ordered pairs, and I drew my line through the points. And lo and behold, it was straight, as it should be, because it's a linear equation. We need to talk about some of the linear equations that result in horizontal lines and vertical lines. Do you remember what horizontal lines look like? They go right to left, like the horizon. Vertical lines run up and down, north to south, like that. Okay, let's look at example A here. It says graph y equals negative 3. Guess what? This is not the first time you've seen something like this. We had to draw these lines that looked like this back when we were reflecting images, back in our previous unit. Do you remember reflecting an image or a triangle across the line where y is negative 3? I bet some of you remember. Maybe not everybody, but I bet some of you do. So let's talk about that line. I told you back then, which was a few weeks ago, think about your coordinate plane. Think about your y-axis. Where is y? -3. Wouldn't you tell me to go down 3 on the y-axis? Well, you should. So here's my coordinate plane. From the origin, I'm going to go down 3 and put my point. There's where y is -3. The line that passes through that point moves right to left, horizontal, and it is always, for the y value, down 3, down 3, down 3, down 3. No matter where you are for the x's, right or left, when it comes to that y value, you are always going down 3, down 3. Now, over here, example B, we talk about a vertical line. Graphing the line where x is 2. Now, I'm going to tell you to think about the x-axis. The x-axis goes side to side, right to left. Where is it 2? From the origin, you would move right 2. So I'm going to do that. From the origin, I'm going to move right 2. There I am. The line that is always x equals 2 is actually a vertical line where no matter where you are for your y values, up or down, it doesn't matter, your x value is always right 2, right 2, right 2, right 2. No matter if I'm down here, right 2, or up here, right 2, it's always x is 2. So it kind of tends to be backwards of what you think. I think a lot of kids look at the equation x equals -2, this thing right here, and they think, oh, x, that is the axis that goes across. I bet that line goes across. And it's not. It's actually the opposite of that. Where x is 2 is actually a vertical line, and where y is -3 is the horizontal line. It's kind of opposite of the axis that we're talking about. One more example. This is kind of a word problem that they're setting up to get you to see that linear equations can be applied to real-world situations. Now check this out. The wind speed y, so they're gonna call the wind speed y. Maybe, there it is, which is in miles per hour, of a tropical storm is represented by this equation. Y equals 2x plus 66. X is the number of hours after the storm enters the Gulf of Mexico. So what it's saying is the wind speed is equal to 2 times the number of hours after the storm has entered the Gulf of Mexico, and then you have to add 66 onto that. So that's the linear equation that represents this real-life situation. So part A asks us to graph this. Well, somebody already chose your x values for you. They are 0, 1, 2, and 3. We are going to solve this thing 4 times. Ready? Here we go. 2 times 0 is 0. Add 66. The answer is 66. Zero, 68. That would be the ordered pair. The next one. 2 times 1, which is 2. Add 66. That gives you 68. That ordered pair is 68, which I just realized I wrote a 68 up here and I shouldn't have. I'm so sorry. Did that confuse you? I'm sorry. How about that? Is that better? Thank you. Sorry. Next one. 2 times 2 is 4. Add 66. Gives you 70. So that ordered pair is 270. The last one, 2 times 3 is 6. Add 66 is 72. So that is 372. So what does this really mean? It means at 0 hours, the wind speed was 66 miles an hour. After 1 hour, the wind speed was up to 68. After 2 hours, it was 70. And after 3 hours, the wind speed was up to 72 miles an hour. Question says, question B, right here. When would the storm become a hurricane? Well, I don't know. What do you know about hurricanes? I don't know very much, but we're told here on this slide that a tropical storm becomes a hurricane when the wind speeds are at least 74 miles an hour. So this is when we reach hurricane status. Well, if you look back at our table, our Y values were our miles per hour, and our X values were number of hours after it came into the Gulf. So after 0 hours, it was going 66 miles an hour. After 1 hour, it was going 68 miles an hour. 2 hours, it was going 70 miles an hour. 3 hours, it was going 72 miles an hour. How many hours would it take for it to reach 74 miles per hour? And obviously, I hope that you see there's a pattern there. And the answer is 4. So after 4 hours of rotating around in the Gulf of Mexico and picking up all that warm, moist air from the warm waters of the Gulf of Mexico, it's still speeding up. It reaches 74 miles an hour, and it's officially now a hurricane. So, could I plot all these points? Yes, I could. It would look something like this. And that would show you that over time, tropical storms do gain speed, wind speed, and speed up and become hurricanes. Okay. We're going to be working on this for about 2 days in class. The first day, I'm going to have you work on these linear equations in class, and I plan for this to be your exit ticket. And then the second day of class, I will have a worksheet for you to do that supports this lesson. It probably won't be out of the textbook, so again, we'll be working on worksheets and packets and things like that. So what do you think? This is your first look at linear equations and the fact that there are equations in math that can be graphed as straight lines. Kind of crazy. But this is only the first lesson. We got a long way to go with this. So I hope you're on board, and I'll see you in class.